product expression for this given function using Quine-McCluskey method. Here we have the minterms provided 0, 4, 5, 7, 8, 11, 12, 15. Let's write this one in terms of binary numbers. So I'm gonna create a table for it. Okay. Now let's look at the numbers. W, X, Y, Z. We have four variable function provided. And let's look at the number given. We have 0 given, and then we have 4 given, we have 5 given, we have 7 given, we have 8, and then 11, and then 12, and then 15. Let's write these numbers in binary form. This one is 0, 0, 0, 0, and 4 mean the weight of this one is 2 power 2, so this is going to be right here, the 1 is going to be right here, and 5 is this one in binary, and then 0, 1, 1, 1, and then for 8 we have 1 right here, and the others are 0, and for 11, 8 plus 3 is 11, so we are going to have 1 here, 0, 1, 1, and then 8 plus 4 is 12, 1, 1, 0, 0. For 15 we are going to have all of them 1. The next thing is we have to group the ones, like group the ones. If you don't have any one, that's going to be the first one. Let's see. So I put the WXYZ right here, and if you look at 0, 0 doesn't have any one, so I'm putting that one first. Okay, the next thing is we group the 1 ones. Okay, let me draw a line for it. We group the 1 ones. What are the values that only has 1 1? We have 4 with only 1 1. Do we have any other things? 8 also has just 1 1, right? So we can group 4 and 8, and other things are like more than 1 once. So I can group 4 and 8 together. So if I put 4 here, that is 0, 1, 0, 0. And if I put the 8 right here, that is 1, 0, 0, 0. Okay, the next thing is we have to look at two ones. What are the values we have with 2 ones? We have 5 with 2 1, and also we have, okay, let's put a check mark for what we are taking care of. We have taken the 0, we have taken the 4, we have taken the 8, and we have 5 with 2 1, and also we have 12 with 2 1. So we can group 5 and 12. 5 with 0, 1, 0, 1, and we have 12, that is 1, 1, 0, 0. Okay, this is 12. So let's put a check mark for these two. And the next thing is, what are the values with 3 ones? We have 7 and 11 with 3 ones. So we can group them together. 7 and 11. 7 has 0, 1, 1, 1, and 11 has 1, 0, 1, 1. Okay. Now we have taken care of this 7 and 11. We only have the 15 left. We put it right here. That is 1, 1, 1, 1. Okay, now we have group this one according to the number of ones we have. The next thing is we have to look at is what are the values that's only changing by one location. So here if you look at this 0 0 0 0, that's why, you know, when you're writing this, make sure you're aligning this one clearly so you can see the difference. So if you look at 0, like only the things with 1 1 is going to be different by one place, the others are different by two places. Here if you compare this 0 and 0, we have two locations that's different. We have one here, that's two location different, so we cannot take that. We have to just look for one location different. So that's only possible with 0 and 4 and 0 and 8. So if we do that, we are going to have 0 4 that is 0, and the location we have different, we put a dash for it. I put a dash right here, and then others are going to be 0. Okay, so once you have done that, we put a check mark for both of them. And then the next thing, if you look at 0 and 8, it's only differs by just one location, so I can take that one here as well. So 0 8, and the location different, I put a dash for it. So here 0 and 8, the first location is different, I put a dash for the first location, and others remains the same, that is 0 0 0. Okay, and there's no other numbers that's with only one location different, so we are done with the first one. So I'm gonna put a line for this. Okay, so now we have taken care of these two, right, from here to here. Now let's compare this 4 and 8 with 5 and 12, or any other number, but 5 and 12 is the best because we are just looking at one location different. That's not possible when you have multiple numbers. So if you look at 4 and 5, what are the locations? How many locations different? One location only, right? So I can take that and put it here. 4 and 5 0. So that first value is 0 1 0. Make sure you aligning with him clearly, aligning all the numbers for together, so it will be easier to do. 0 1 0 and only this location is different, the last digit is different, so I put a dash for it. And let's compare 4 and 12. I cannot do that because 4 and 5 I already taken care of. Once it's done, it's gone. So the next thing is I had to compare 8 and 12. 8 and 12, how many location different? Only one location different. So we can take that. So 8 and 12. 1 dash, and the others are 0 0. Okay, that's it for this one. Now we have taken care of these two, 8 and 12. Now let's compare this 5 and 7 and 12 and 11. 5 and 7, how many location different? Only one, right? And this middle part is the only one that's different, so I can take that. 5 and 7, and if you put that, it's going to be 0 1, and whatever the location different, I put a dash for it, and the last digit is 1. Okay, now we have taken care of 5 and 7. Now let's compare 12 and 11. 12 and 11, how many location different? We have one location here, one location here, so two locations different, we cannot take it. So we cannot take that 12 and 11. So let's move to the next thing. 7 11 with 15, compare both of them. 7 and 11, 7 and 15, how many location different? Only one location. So let's put a line for it first. 7 and 15, only the first location different, so I put 7 and 15 here. 7 and 15, that is dash, 1 1 1. How about 11 and 15? Only one location different. So 1 dash 1 dash 1 1. Okay, now I have looked at the differences. Now what I have to do is I have to continue again. Let me look at the another. Can I find anything else with one location different? Here we have 0 dash 0 0. And the dash have the one thing is dash has to match and one location different. So second location dash, how many of them with second location dash? We have one here, one here, one here. If I compare this one and this one, second location dash matches and only one different, right? The first digit is only different. So I can take this one. This is 0 4. Let's put a check mark for it. 0 4 and 8 12. So this is going to be right here. 0 4 and 8 12. 8 12. And this is going to be what? Dash dash 0 0. Okay, now we have taken care of this. Can I do it for anything else? Okay, two location we taken care of. Because if you look, compare this two, this second dash and this one has too many difference, three different. We only need one. We only want one different. If you have more than one, we cannot take it. So we are taking care of this. So one second dash is done. Let's look at this one. This one has a dash in the first place. Do we have anything else with the dash in the first place? Yeah, we have here. But how many difference? We have more than one. We have three difference. So we cannot take this. Let's look at this 4 and 5. We have a dash at the end. Do we have anything else with dash at the end? We don't have anything else, so we cannot take it. What about this? One dash. That's we already taken care of. And we don't, if you compare, we don't have anything else. Right? How about third place dash? We don't have anything else. First place dash, we already taken it, like we don't have anything else. So like this, that's it for this one basically. But here you can see yeah, that's basically it. Yeah, so that's it. Only these things we have taken care of. So here, like you have to look at all the numbers we have. In this one we have 0 4 and 8 12, and here we have this one also contains you know what, I made one mistake here. When I compare, yeah, the 412 also one of the comparison. 412 only one location different. I didn't write that one right here. 412 412 has like one location different, that is dash gonna be there, and then others are going to be remain the same, right? 1 0 0. So that's going to be here as well. So if I do that, like, okay, so now we have this one in the first place, and this one differ by just one location. It means we can take these two as well. Okay, let's write this one. So if I take 0, 8, 0, 8, 4, 12, what's going to be the value? We are going to have dash and then 0, 1. That's also going to be dash. The one difference, dash, dash, 0, 0. And if you look at these two are exactly the same. The upper one and the one, we just rearrange this number like 0, 4, 8, 12. The same number, right? 0, 4, 8, 12, 0, 8, 4, 12. It's the exact same. We are just rearranging and the numbers are same, so we don't have to write it twice. But we can put a check mark for it. Check mark mean we are done with that. We are done with this one, this one, this one, this one. Others are going to remain the same. Now the next thing is we are going to write the expression for whatever the things without the check mark. So I'm going to create a table for it. So once we are done, we can forget about all these things. Let me actually erase these things because we only need these things. Okay, let me highlight the things we needed. We need the things that's without check mark. We need let me use a different brush here. I need a highlighter. And I highlight with this. Oh, why it's not working? Is something weird happened? Okay. Let me erase this one. Let me see if the highlighter works. Yeah, it's working. Okay, so we only need the things that we didn't put a check mark. So this one we needed. I better choose a different color. Yeah, this one we needed. This one we needed. This one we needed. This one we needed. This one. These are the things we need. Other things we can get rid of it. Okay, let me erase the other things. Here I'm gonna create a table for it. Okay, so we have 4 variables, wxyz, and then the numbers provided are right here. Let me write all those numbers and stuff. This one is WXYZ, and this one is we have 0, 4, and then 5, and then 7, and then 8, and then 11, and then 12, and then 15. Okay, so let's look at the first value. First value we have 0, 0 at the end. So these are all WXYZ, WXYZ, WXYZ. So in this one, WXYZ, if it has dash, get rid of it. So dashes are gone. Y and Z, both of them are 1. Here we have min term provider. I mean, I had to do a complement for it. So Y complement Z. That's one of our thing. And that's happening in which location? 0, 4, 8, 12. We put X marks for the location. 0, 4, 8, and 12. And the next thing we need is this one. Eliminate the dash. Eliminate the dash. And others with 0, 0 put a complement. So here 0 under W. I put a complement for it. W complement, and X remains the same. X is the 1, so it remains the same. Y we put a complement for it, and this happening in the location of 4 and 5. I put X for 4 and 5. And then what are the things without mark? Here we have another one. Get rid of the dash one. So here we have W, X, and Z. W is 0, so we put a complement for it. And then 1 we have, 1 is a X. We keep it as it is. And then we have Z, that's also 1. We keep it as it is. Okay. Now we have done this. Now this one. Also this we okay, wait a minute. I have to put a location for this one. The location is 5 and 7. And the next thing is 715. 715 is the first one is eliminated, and then we have XYZ. What is the location? 7 and 15. Put an X for 7 and then X for 15. Okay. Okay. Yes. So this one is done. We have this one 11 and 15. Like this is X. This is W. X is eliminated, and YZ. WYZ. The location is 11 and 15. Okay. In Quine-McCluskey method, what happens is we have to look for the x's and connect them horizontally. When you connect them, okay, it's better to do with a highlighter. When you connect them, yeah, connecting this. When I connect this, if I see anything vertically also can't connect, this will be included. So here at 4, we have another one as well. That's why I connect these two. And do I have any other location that matches with other x's? No other location. So just leave it. And when you do it, you have to be like careful. Like you have to look at if you take which one that will include maximum x's. So you have to consider that when you're doing it. And here, if I take this bottom one and connect this, there's an x in this location, right? So these are taken care of. Now here you have to be a little bit smart, like Don't go for this one, because if you take the middle, it gonna cover everything, right? So these are the three expressions we are gonna need. The final expression we are gonna have is y bar z bar plus wyz, and then w bar xz. Okay, this is the one we got using Quine-McCluskey method. This is the long one compared to K-map. This is the long one. This is the old method. You know, they teach you it's better to know what we had before K-map. But K-map is much simpler. You can actually verify this one using K-map. Let's actually see that. Let me see that. This is the 4 input K-map. I'm gonna need some space, so I'm gonna erase this thing. Just to verify, let's do the K-map. So this is the 4 input K-map. So we are gonna have 2 power 4, 16 locations. And see if I am getting the same answer here. Okay, let's put the values in the K-map. K-map wxyz 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. This location is 0, this location is 1, this is 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, let's put the values given. We have 1 at 0, we have 1 at 0, we have 1 at 4, we have 1 at 5, we have 1 at 7, we have 1 at 8, we have 1 at 11, and we have 1 at 12, and we have 1 at 15 right here. Okay, so 4 is, 8 is better than 4, 4 is better than 2, 4 is better than 2, 2 is better than 1. 8 is not possible. So the next thing is, can I connect anything as 4? I can connect these as 4. And can I connect anything else as 4? No, there's no other way. So can I connect anything as 2? Yes. You can see these two. Let's do the expression. For this part right here, what's the expression? Why w and x are changing? W is 0 here, 1 here, so it's changing. X is 0 here, 1 changing. So both of them are eliminated. And since this is happening in the same row, y and c is going to be same here, because you see 0 0. And since y and c are 0, I have to do complement for it. Y complement, c complement. And let's look at this one. This is happening in the same column, so wx is same, 0 and 1. W is what? 0. So we have to put a complement. X is 1. X is 1, so it's going to remain the same. And what about y? Y is changing, 0 and 1 changing, so eliminated. Z remains the same, 1 1. So w bar xz, and plus what else? We have this one remaining. This one, if you look at w is not changing. W is 1 here, 1 here, so w is going to be there. X is changing, 1 0 changing, eliminated. How about y and z? Y and z remains the same because it's happening in the same row, 1 1. So it's gonna be wyz. Okay, let's compare the expression. W bar c bar, wyz, w bar xy xz. We are getting the exact same expression. See, this one is K-map is very fast. This one take a long, Quine-McCluskey method take longer, and you had to be paying attention when you do that, because if you made a simple mistake, it's gonna ruin everything. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.